So this is the Foundation Double Award 2023 paper. So the first question, quite nice and easy. So you've been given a load of different smart materials and you have to talk about which one you would use in each material, or each object. So disposable nappies, that's hydrogel because they can hold up to 10,000 times their volume in water. And then lenses for sunglasses would be photochromic because they change colour in light. So they change colour, so they make sunglasses. What must be done to the photochromic pigment for it to change colour? You heat it, apply temperature to it. Nice easy question to get you started. Second bit then is talking about giant ionic structures. So that's ionic bonds over and over again, so repeated over and over. Draw a line from the diagram, use your diagram, and the knowledge of to draw one line from the property to the correct explanation. So it's got high melting point because there's strong bonds between the ions. It conducts electricity when molten or dissolved, when free to move. It's very similar to just one ionic bond, but that is obviously giant because it's over and over again. Then it's a simple covalent bond. Remember, covalent bonds are non-metals sharing electrons. And the same kind of thing. Why do they have low melting points? Because there's weak forces between the molecules. These bonds here are actually quite strong, but it's the fact that there's no bonds between the molecules that makes it have a low melting point. Does not conduct electricity, they don't have a charge, and they aren't free to move. Diamond and graphite are giant covalent structures. Remember, they're allotropes of carbon, so just carbon bonded over and over again. Thinking about diamond, that's got 4 bonds, four carbon bonds, and then graphite's got 3, remembering it's got a free electron. Diamond is used in drill bits because it's hard and has a high melting point. Really nice question. Graphite is used in pencils because the layers of the atoms are weakly held together and able to slide over each other. Second question then, looking at some blast furnaces. Again, lots of words to use here. Choose the substance of the box to complete the following sentences. Iron, oxide, coke and limestone are the materials fed in the top of the blast furnace. The blast furnace is heated by burning the coke in hot air. Remember, the hot air is where we get the oxygen from. It's the oxygen we need in the hot air. Complete the symbol equation. You have got, if you were to split it, reactants and products. You have got 2 ions on this side, so that means you're going to need 2 ions on that side. Looking at these then, how would you work out the MR? Relative formula mass, that's just another word for MR. So you've got 1 calcium, which is 40. You've got 1 silica, which is 28, and 3 oxygens. That's a really nice question again. 180 tonnes of iron was extracted from 1,750 tonnes of iron. Calculate the percentage of iron in the ore. So that's how much iron we had. That's how much the whole thing weighed. Divide it by each other and then times by 100 to work out a percentage. Nathan and Simon were investigating the reactivity of metals. In one experiment, they investigated the effect of adding dilute hydrochloric acid to 4 different metals. State the same volume of acid was used in each tube. State 2 other ways the dilute hydrochloric acid to ensure a fair test. So the mass of the metals, each metal should have been the same mass, and then the concentration of the acid. Use your observations to list in order of reactivity, give your reasons for your choice. So you're looking for the one that reacts the most, and that's going to be B. It's got the most bubbles coming off, and then A's next, D and C. More hydrogen bubbles produced, more reactive. In the second experiment, Nathan and Simon used the following apparatus to investigate the temperature rise of metals A, B, C and D were added to hydrochloric acid. Identify the errors in the way the apparatus is set up and state how you would collect the results. So first off, you can see here the thermometer is not in the solution. So the thermometer is actually measuring the temperature of the air, not the solution. And then the effect is that it would be measuring the temperature of the air, incorrect temperature reading. Once they set up the apparatus correctly, they obtained the following results. Identify the anomalous result. From what metal and from what test. So it's 9 there, I've circled it because it doesn't fit and it's not how you would have calculated the mean. And then calculate the missing result for metal A. So we've got a mean and we've got two results. So I took it to be x, so we had 22 plus 21 plus x, which is that space there, divided by 3 equals 22. So then I rearranged my equation and I ended up with 23. Zinc is more reactive than metal C and D, but less reactive than metal A and B. Use the information to predict the temperature rise which would be expected for zinc. So it's going to be somewhere in between 14 and 22. So I went for 18, but you should have got a mark for any number in between 14 and 22. The reaction of metal with acid is summarised by the following equation. Give the formula for the metal magnesium chloride and then balance the equation. So if you wanted to, top, swap, drop. So magnesium's 2 plus, chloride is minus. So magnesium 2, chloride 1, magnesium 1, chloride 2, magnesium, chloride 2. So you could have done that. And then because we had 2 hydrogens on this side, that means we have 2 hydrogens on that side. Give the name of the salt for my magnesium reacts with nitric acid. Remember, nitric acid makes a nitrate. Then there was a lot of information to read from, okay? So this question would have definitely been testing our literacy skills, having to read through and extract information. The statement that best describes where metals are positioned within the periodic table, and then that answer was within the reading, okay? Name the element in table 1 that is a liquid over the biggest temperature range, so Ti or titanium. And then again, from extracting information, these two would have been the correct answer. Consider the following statement. It is possible to tell the group 1 and transition metal parts apart by the colour of the compounds they form. Use information in table 1 to give one reason to agree and one reason to disagree. So reason to agree, if a compound is coloured, it must contain a transition metal. Reason to disagree, titanium is also a white compound, so it's quite hard to say that it would form a colour change. Blank page. Next thing is then completing a titration. Nice kind of easy question to put them in order of how the method should actually go. So they start with F and measure 25 centimetres cubed of alkali into a chronicle flask. Then add 2 to 3 drops of indicator. Add the acid to the alkali until the indicator changes colour. Place the salt solution in an evaporating dish and heat until half the volume of solution remains. And then C, allow the solution to crystallise naturally. Give the letter, the step A is most likely to let error to occur, give the reason for your choice. E, add too much acid and then you overshoot and then you don't get a correct volume of acid. The reaction between an acid and alkali produces salt and water. The following equation shows how potassium sulfate is produced from an acid and an alkali. So give the name. So if it's sulfate, it's going to be sulfuric acid. And again, chemical formula. So it's K plus, sulfate is SO4. 2 minus, so you can do top, swap, drop again. So K plus SO4, so K1 SO4 2. Remember that 4 just stays there, okay? And then K2, and then I'm going to get rid of that 1 because we don't really need it, it's only one of them. Okay, so be careful you don't lose that 4 in the process. So a nice easy kind of 6 marker is they gave you a table and they said describe how the properties are linked to the uses of aluminium, copper and titanium. You should not give more than 2 uses for any metal. So there's loads of information about different metals and you had to be able to give at least 2 uses. So aluminium is used in aircrafts, window frames, saucepans. Copper is used in electrical wires, saucepans, coins. Titanium is used in helicopter rotor planes, replacement joints. Now that, if you could have just done that, is likely to get you 2 to 3 marks, okay? But then you had to kind of link the properties. So aluminium is used in aircraft because of its low density and resistance to corrosion. You didn't even need to know that because it was in the table, as long as you could extract information from the table. Copper is used in saucepans because of its high melting point and good thermal conductivity. Titanium is used in replacement joints because of low density and good resistance to corrosion. Another blank page. The molecular formula of 5 carbon compounds A, B, C and D are shown below. Give the letters of 2 compounds are alkanes. Okay, alkanes are CnH2n plus 2. So we're looking for something that's doubled plus 2, so that would have been E and D. Give the name of compound A. So compound A is propane, 3 carbons, and it's an alkene. And then draw the structural formula of compound E. The following diagram shows the 2 reactions of ethene. First one is adding bromine water, so you get rid of the double bonds and the BRs added instead. Second one then is making it a polymer, repeating unit, so get rid of the double bonds and kind of straighten it out. Describe what would be seen when orange bromine water is added to molecule X. It will turn colourless. Name the type of reaction that takes place to form repeating unit Y. That's polymerization. Plastic bags. Paper and plastic are both used to make disposable plastic bags. The table shows the percentage of disposable paper plastic used by consumers in a Welsh town between 1988 and 2018. In 2003, the consumers of the town used a total of 125 million disposable bags. Use the information in the table to calculate the number of paper bags. Okay. So you want to do 12 divided by 100 times by 1.25 million, and that was the number of paper bags compared to the number of plastic bags. Then you had to plot a graph. Okay, I've done this on my iPad, and that isn't a lovely kind of line, but it does follow through, and you can kind of see that it goes up and down. So it would have been 2 marks for plotting the points. And then 1 mark for your line. Give the year where the number of plastic bags is equal to the number of paper bags. You can see on the graph, obviously it's on your graph, it's a bit harder for me because it's not going to flick back, is that there was a point where they cross over each other, and that was 1996, so that's where they're the same. Give the simplest ratio for the number of paper bags to plastic bags used in 2000 and to just 2000 is 1 to 4, and give a reason that explains the change between the plastic bag usage for Wales between 2008 and 2018. It was when we started charging the 5p for the plastic bags. That's most probably why there hasn't been as much usage since then. And then if you need the additional page, and then you've always got your table of ions and a periodic table right at the back.